This is the Vernier pyronometer. It's designed to measure total solar radiation. So what you're doing is measuring the illumination as a function of watts per square meter. So the obvious usage with this would be maybe a solar panel experiment. Maybe you're looking at the power output as a function of angle or different kinds of solar panels, things like that. For this experiment, what I've done is I have already hooked up a Vernier high current sensor and a Vernier 30-volt voltage probe to the setup here, and I'm going to measure the power output of this setup over a function of time. So I'm actually going to let it run for a couple of hours, and then we'll take a look at some data here. Now, the pyronometer, there's a couple things about it. The actual sensitive part is under this little dome right here, and so this needs to be mounted vertically with the cord facing north if you're in the northern hemisphere, or south if you're in the southern hemisphere, with this aimed straight up. It's got an angular compensation for it, so as the sun crosses the sky, it can measure that. It's intended to be straight up. Now, the case is actually weatherproof, so you can leave it outside, and it comes with a 6-meter long cord for that. So the idea is that you might mount it on the roof and then have this piece of the electronics inside to be able to monitor the solar radiation. For mounting, there's actually a screw here, and so you could take it out and then attach it to something and be able to screw it onto there. So to collect data with these 3 devices, what I will do is plug them all into the LabQuest 2. And so if I plug in, say, the voltage probe, and then I plug in the current probe, and then the pyronometer, I will have all 3 devices running at once on the LabQuest. So we've got all our sensors plugged in here, and one of the things I would like to do to make this easier to see outdoors is change my LabQuest 2 to a high contrast mode. And to do this, I go under the little house icon there, go to Preferences, Light and Power, and down in the lower left-hand corner I can check High Contrast, and then it'll be easier to see out here in the sunshine. Now that we've set the screen to high contrast, and we see our 3 sensors there, we might want to take a look at our default collection parameters. Its mode is time-based, so it's going to be looking at these different variables as a function of time. The sample rate is 0.017 samples per second. That's actually once every minute, and the duration is 86,400 seconds. That's actually a 24-hour collection, so it's designed to track solar radiation throughout an entire 24-hour period. So now we have all of our sensors plugged in and our pyronometer in place. We'll be ready to collect data, and so if I collect data, it's going to start collection, and it would collect data for 24 hours, or in this case maybe until the battery ran out because I'm not plugged in. And so it's going to be able to do that. Now, I'm actually not going to let it run and collect the data here. I'm going to share with you some data that I've collected previously to be able to show you what the data might look like. I'm going to go File, Open, and I already have some pyronometer data, so I'm going to open it up instead, and we'll take a look at that. We can discard whatever we collected this time. So I've got the same sensors for this experiment, but I want to go over here and actually look at a graph. And what I have here is kind of interesting. The upper graph is the graph of irradiance in watts per square meter. So we see it, and I started kind of midday and had it collect over a period of time, and then it went down. And the interesting part is this is where the sun went behind some trees late in the day, and of course the irradiance dropped very down. This column, or this graph here, is actually a calculated column with watts, because we were collecting with the current sensor and the voltage probe, and I had it calculate the power output. So it had the product of the current and voltage together, and that's actually what is being displayed here. And so we're seeing the relationship between the irradiance and the power output in watts down here. To see that in the column, if I go over to the data table here, we can see that I have that, and the watts column here, if I click on it, we can see that it's actually, I named it power, the units of watts. The equation that I put in there was XY, and I set X to be current and the potential to be Y, and it calculated that, and that's what I showed on the graph. Now if we go back to here, you see that there's a little drop in the data at one point. I don't know exactly what happened because I wasn't there. I suspect that maybe that was a cloud passing, and it just happened to be at the time that I was collecting data. The day that I collected this was very sunny, but there were the occasional high cloud passing by, and so that it dropped down there. So the pyronometer makes an excellent addition to the study of alternative energy, maybe with a solar panel, and so it can be mounted long-term, so long-term data collection. So it's a really nice device for those kinds of experiments.